this is Mr. Thompson, and I'm going to show you how to do some very basic materials testing in Inventor. As you know, my 12 engineering class, we are doing a virtual prototype this year rather than building a physical balsa prototype. But we need to do materials testing somehow or other. That's what the syllabus requires of us. So how do we do materials testing virtually? So what we're going to do basically is we're going to build a little universal beam like this, and we're going to apply a force to it, and we're going to use Inventor's simulation tools to simulate the displacement, to work out the displacement of our beam if we build it in different materials. So let's get started. I'm going to go File, New. Now I've changed the resolution on my screen to make it big so you can see what's going on. So if it looks a little bit clunky, that's why, but we'll see how we go. All right, so I'm going to click on New here, and I'm going to click a metric standard in millimeters part. So if I click on Create there, like so. All right, and so I'm going to start a new 2D sketch, and I'll click on my XY plane to create the sketch. Now, I went and did a little bit of research, and I found this on the internet. Here we go. That's just a diagram, a dimension diagram of a universal beam. That one there is a UB 150-14. That means it's got a height of 150 and it's 14 kilograms for every linear meter. So using those dimensions, I'm going to draw myself a I-beam. So I'm just going to click on the line tool, and I think the easiest way is just to draw something that looks like an I-beam, trying to keep my lines vertical. See that, you can see that little perpendicular sign there, which means that it's recognized that I wanted a right angle there. That's good. Come up to here, keeping my line vertical. Using those, see that line that appears that shows that I'm nice and aligned. If I use those alignment lines, don't know what they're called, but that'll just make things, there we go. That'll just make it easier to get it right, like that. And I haven't got my dimensions right, and that's okay because I'll fix that up in just a moment. Click from there to there. There we go. So there's my basic I-beam. Now we need to dimension it. So, or actually, yeah, let's do that. D for dimension. Now looking at my dimensions, if I click that one needs to be, that one needs to be 75. Well, actually, you know what? That's going to do weird things. Oh, no, that's all right. That's 75. Good. Okay, and it needs to be 150 from top to bottom. So I'll make that 150 like that. Let's see, these flanges here need to be, click there and there, that distance there needs to be 7 millimeters, like that. Now this one here also needs to be 7 millimeters, but I'm going to use an equals constraint. So if I click on equal, I say I want that length there to be equal to that, that length there. So did that work? Yeah, that worked. Okay. Now while I've got my equals constraint active, I'm zooming in and out using the wheel on my mouse. So if you haven't got a mouse with a wheel, I guess you could pinch and unpinch on your trackpad on your laptop, but using a mouse with a wheel is so much easier. So that needs to be equal to that. Oh, actually that didn't work. Let me Control Z that. Let's try that again. Equals, that one has to be equal to that one. Okay, that's good. And this distance here, so D for dimension again, that distance between there and there needs to be 5 millimeters, like that. Now I want it to be, centered. So I'm going to align vertically. So I click on that vertical constraint. I'm going to find the midpoint of that line there, and I'm going to line that up. I'm just going to zoom in and line that up with the origin, like that. Good. And then I'm going to use the horizontal one there. I'm going to find that midpoint there, and I want that midpoint to line up with the origin. Now it's really important that you get your shape symmetrical, because once we add forces to different to different faces. If we haven't got a symmetrical shape, it's going to twist and warp our beam. So I'm pretty confident that that's symmetrical now, and it's centered on the axis, and I think everything there looks pretty good. So I'm just going to hit escape a couple of times. Yeah, and everything's black, which means it's fully constrained. Okay, so I'll finish that sketch, and now I'm going to extrude that sketch into a beam. So I click on extrude, and now I'm just going to, I want it to go that way. And how far? I think 10, and M for meters. If I don't put any units, it'll go millimeters. I want 10 meters, so I want a nice long beam. Maybe that's excessive, but I want to see some reasonable deflection when I apply force, so I'm making a nice long beam. So enter there. There's my 10 meters. There's my beam. Now, what material do we want to? What materials would we like to test? If I come across to tools, and or actually, you know what? That extrusion, that's my beam. So I'm just going to call that beam rather than extrusion, like that. Now, not appearance. Appearance is just the color that it is. I don't care about that. It's what material we're going to use. So if I click on materials, and it pops up this material browser. Now, I haven't worked out a way. I do this as a two-step process. There's probably a quicker way. Maybe you can work out the quicker way and tell me. But here's what I do. I'm going to go through and find out the materials I want. I want to use aluminium, so I'm going to double click on aluminium. Then I'm going to close that window. I also want to test, I'm not interested in brass or copper or gold or nylon. Let's come down here. Stainless steel, let's test stainless steel. So I'm going to double click stainless steel. Now it's in my, in my document. I might use, let's see, mild steel. Let's try that. Oh, double click on mild steel. There we go, that worked. There we go. And let's see, have I got galvanized? Yeah, galvanized. Let's do galvanized steel. I would expect galvanized steel to behave the same as mild steel because of obviously the galvanizing is just a coating, but that would be interesting to see, wouldn't it? And titanium, why not? Spare no expense. Let's test titanium just for fun. All right, so they're all, now there should be a way of selecting or dropping but I don't know what it is. So I close that. Then I click on beam again, and then open up materials, and then I can select, let's start by doing, I don't know, mild steel. So now see how it's gone bold? So now that component there, or that beam, if I want to double check, click the beam, click material, mild steel. So it's definitely made out of mild steel. Well, it's not really, it's virtual, but it's Inventor is going to treat it as if it's made of mild steel when we do the simulation. So let's do the simulation. I'm going to come over here to environments, and I'm going to do some stress analysis. Now I'm going to do two studies. A study is just a test. Yep. So create a study. The first study I'm going to do, let's just do a tensile test like that. So a tensile test, and I'm just going to come down here and click on OK. Well, your dialog boxes should be smaller because, like I say, I've mucked with my resolution so you can see exactly what I'm doing. All right, now I'm going to, let's see, there's my tensile test. We need to apply a constraint, so we need to make sure we're holding one end of the beam, and then we need to apply a force on the other end of the beam. So I'm going to use my mouse wheel and hover the mouse near the end here so I can zoom in and see that end there. And I'm going to click on a fixed constraint. So a fixed constraint means that face, I'm going to click on the face, not the edge, not a corner, on the actual face, like that, and then go OK. And so you can see now we've got a fixed constraint on that face, which means that face can't move, but it also can't rotate. So it's different to a pin or a roller joint or a sliding joint. It's a fixed joint. Wouldn't have mattered if we used a pin joint, but I'm going to use a fixed joint there. All right, now I'm zooming out again. I'm going to use my view cube to rotate a little bit so I can see the other end, and then zoom in the other end. This is the end that we need a force on. So let me just zoom in. I'm going to click on force, and I'm going to apply a force again on the face, not being careful not to apply on the edge, but on the actual face itself, like that. And if I zoom out a bit, you can see it's giving me the direction. See how that force is a compressive force. I actually wanted a tensile force, so I'm going to click on direction, and like that. There we go. So that's toggled the direction, and let's do about 100 kilonewtons. Whoop, pressed the wrong button. 100 kilonewtons, like that, and we'll go OK. All right, so there's, and we're ready now. I click on home, so it's looks nice. Okay, we're ready now to do our simulation. So let's do simulate and run the simulation. One or more thin bodies are treated as solids. That's okay. We're going to click on run. Okay, there we go. Now, it tells us the stress. Now, stress, I don't really care so much about the stress. Well, I guess we could record the stress. The stress is going to be the same for all the materials though, isn't it? Because the stress is a function of a cross-sectional area and the force. So the stress won't vary from material to material. So you could record that, but it's not real. The really interesting thing is the displacement, because different materials will displace by different amounts. So if I come down here under results and double click on displacement there, it shows me that we've got 2.6 millimeters of displacement. And we can see there, see that stretch there? Up here, if I put it on actual, it shows me it's only a tiny little bit of a stress, or we can do adjusted. So there's the adjusted stress. It exaggerates so you can see what it's actually going to look like. But that's the figure I'm interested in. So what I'm going to do is I'm going to put that into a table here that I've created. Let's see, what was that? Did we say that was mild steel? I think it was mild steel. Let's assuming it was mild steel. It was 100 kilonewton tensile test displacement, and we said it was 2.627 millimeters. Okay, enter. All right, now, put that back on my other screen. Now I'm going to do another test. I want to do a bending test. So I'm going to create another study, and this study I'm going to call bending test. Bending test. Oh, I don't know what happened there. Okay, bending test. I must have hovered over something. So I'm going to go OK there. Okay, and again, I'm going to do almost the same as I did last time to start with. I'm going to zoom in so I can see that face there. I'm going to put a fixed support on that face there, or fixed constraint on that face there. And then I'm going to zoom out. I'm going to rotate with my view cube, and I'm going to come back in here, and this time I'm going to put a force, but this time, so coming in closer there, put a force there. If I zoom out, now that's a compressive force, it's an axial force. Now remember, we wanted a bending force, so I'm going to use these buttons here, open or close the extra part of this dialog box. So I'm going to use vector components, and I want a force in the y direction, and what I want is minus 1,000 newtons. I'm just going to use one kilonewton, or 1,000 newtons. If I press tab, there we go, that's what I want. I want a downwards force, not an axial force. So minus 1,000 newtons, and I click OK there, and we're ready to simulate. So if I click on simulate there and run, and away she goes. Takes a little while. Okay, and there we go, we're done. Now again, I'm not interested in the stresses. What I'm really interested in is the displacement. And we can see, if I click on displacement there, there's a displacement of 241.8 millimeters. So if I come over here and add that, oh, I deleted my other one. I'll have to go and fix that. So my bending test was 248.1 millimeters. And my tensile test, let me just go back and have another look at that one. My tensile test results displacement there was, what do we say, 2.627. Let me write that in again. 2.627, like so. All right. So we can see that that bending test caused a lot more displacement, even though it was a smaller force, just because a steel beam is going to be a lot more resistant to a tensile force than it is to a bending force, especially at 10 meters away from the support. Okay, now we want to do different materials. So if I finish that analysis and I click on my beam and then go to Tools and Materials, let's do those same tests. This time let's do aluminium. So if I click on aluminium like that, so it's bold, then I can close that. Let's just double check that that worked. If I click on beam and click on material, aluminium's bold, good. So now it's made of aluminium. What if we run the same tests? Now, we don't have to set the tests up again because they're already saved. So we can just go to stress analysis, and there's our tensile test. Can you see the little lightning bolt? That means I've got to run the test again. Those results aren't valid. So all I do is click on tensile test, simulate, run. Okay, there it is. And let's have a look. What did we do? Displacement, double click on displacement. I guess I'm expecting more displacement from aluminium. Let's have a look. So my mild steel was 2.627 and aluminium is 8. So that's, I'd expect that actually, 8.387. like that, millimeters. And let's do the bending test and see how that goes. So all I've got to do is just click on the minus button there, double click on the bending test. And again, my results have that lightning symbol on it. So I need to simulate again because I've changed the materials. So run the tests again. So you can see that running the tests for your second and your third and your fourth and your fifth material is a lot easier because you only have to set the tests up once. Here we go. And we've got, if I come down again to displacement, 818, so almost a meter displacement. So that's a lot more, isn't it? So if I come over here, 818 millimeters of displacement for the aluminium. So I won't do all the others, but you get the idea now. So that's a way that you can do some materials testing to satisfy the criteria using Inventor, and we can do it all virtually. Now, could we have just looked this stuff up and calculated it? Yes, we could have. But it's a good exercise to learn how to do these simulations in Inventor. And the syllabus requires that we do some materials testing. So there you go.